Welcome to another edition of Comet Algebra. This video is for Algebra 2, Chapter 6, Section 2, about quadratic functions. So I'm going to start here with a little review because we need to learn to recognize what the graph is going to be by looking at the equations. So we're going to work on this skill all year. So looking at the directions here, describe the graph of each. Letter A says it, and if you look kind of comparing A and B, we notice right away that there is no y here in A. We only have an x. Therefore, what the graph of this one would look like, it's a one-dimensional graph. It would just be a dot at that location on a number line. Now looking at B, hopefully you recognize we see an x, we see a y, there's no x squared. So we know that this is going to graph into a straight line that is on the xy coordinate plane. Seeing an x squared, we recognize this as a quadratic, and this will graph then as a parabola on the xy plane. Again, that's just in a review. We're going to try to touch on that several times this year to keep our skills sharp on recognizing the graph by looking at the equation. A bit of review now from 6.1. We learned that the way we write the general form or standard form of a quadratic is the x squared term, the x term, and then the constant. One of the things we're going to talk about today is to be able to move from the general form into the vertex form. And we'll also be going backwards from the vertex to the general. To go from general to vertex, you need to, yes, it's back, complete the square. So since this is what the general form looks like, you need to know this is what the vertex form looks like. H and K and A are just numbers. And we'll talk more about A in a minute. HK is the vertex of the parabola. Remember in our work on that worksheet where we moved the parabola around, what's happening in here moves the parabola left and right. What's happening with this number moves it up and down. So something I wasn't quite sure how to put into your notes, you need to realize that this H here in the parentheses has a negative sign, and this H right here does not. So you have to catch, this is that opposite thing. If this H is positive, this H is negative, and vice versa. So somehow put in your notes that this H has that opposite thing going on. The K, however, does not. If this is positive, it's moving the parabola up, negative, moving it down. This K just matches this K. That's how we find the vertex from the vertex form. The other thing we're going to be asked to find is the line of symmetry. You recall that's the line that cuts the parabola in half. And the equation of that line, it is a vertical line when the parabola is open up and down, is the equation is H equals whatever number, X equals whatever number this H is. And again, notice it's the opposite of what's inside the parentheses. So let's look at an example of this. If we had this equation, y equals 2 times the quantity x minus 7 squared minus 3. If this is our vertex form, and we are asked to state the vertex, so we look inside here for our HK. The H here is negative 7. That means the parabola is moving in the positive direction. So the vertex would have an x-coordinate of positive 7. This negative 3 does move the parabola down, so then the vertex would go down 3. So that's the vertex. And then the line of symmetry, we need to find that equation. This parabola opens up because this A is positive, and so we know the line of symmetry is going to be a vertical line, and it is going to pass right through the vertex. That's why this vertex is handing us the answer. This vertex came over 7, so the line of symmetry is going to cut right through that, and the equation would be x equals 7. So you can find the vertex and the line of symmetry when you're given the quadratic in vertex form. This example, we are asked to take this standard form for a quadratic and write it into vertex form. And the strategy we just learned on the previous screen was that we need to complete the square. So let's set up this quadratic for completing the square. I'm going to leave a blank and bring that 1 over to the other side as a negative and put a blank there. Cutting this 3 in half and squaring it would complete the square. So 3 halves squared, I would be adding a 9/4 to both sides. Factoring this on the left gives me x plus 3 halves quantity squared, and then change this -1 into -4/4, and then we can add this -4 and 9 is 5/4. Now this doesn't quite look like vertex form yet because this 5/4 is on the wrong side. So I need to bring it over to the other side of the equal sign. And then I can write this f of x in vertex form is x plus 3 halves quantity squared minus 5/4. So I have done this part, I've changed it to vertex form. What is the vertex? Well, we just pull it out of here and here. Remember, it's the opposite of this, so it would be a -3 halves, and we just keep the constant the same. Is this a min or a max? Well, to do that, we look at what is happening right here. The letter A, in this case, that number is 1, and this 1 is positive. And if that leading coefficient is positive, the parabola opens upward. Therefore, this vertex would be a minimum. Describe the shape compared to the parent. Well, this A here is 1, so we have not made it thinner or wider, so it has the same shape, but we have moved it, it has translated. This -3 halves means that we have moved it to the left 3 halves, and this one we have moved it down 5/4. And since I said left, I don't need to say negative, but you could if you wanted to, and same thing with down. What is the equation of the axis of symmetry? Remember, that line goes right through the vertex. It is a vertical line, so it is an x equals equation, and the x coordinate of the vertex is -3 halves. So that is the line of symmetry. All right, this example is a very big deal. Really pay attention to this one. We are asked to write this standard form in vertex form. But what's different is now we have an x squared coefficient. We deal with this differently than when we are solving for the two answers because our goal is not to solve. Our goal is to make it look like this vertex form. So we have to keep our goal in mind so that we take the steps necessary to reach that. So the first thing I'm going to do is get this ready for completing the square. I'm going to take, I'll leave a blank here, take that +1 and move it over to the other side, -1. Now, instead of dividing everything by -3 and it's gone, in order to keep this parabola, we have to keep all the numbers in the vertex form of the equation. So you cannot just get rid of the -3, but you have to deal with it. So we're going to GCF it out of these terms only on the left side of this equation. So I'm going to take the -3 out of the x squared and take the -3 out of the 6. I'm still going to leave room for completing the square on both sides. Now, you'll notice this -1 has absolutely nothing to do with this -3. It's not being multiplied by it, and that's true here. This k has nothing to do with this a, so I'm setting it up this way to lead me to my goal. Now we want to look at completing the square, just this little piece, just what is inside these parentheses is all I'm focused on right now. Don't look at the 3, don't look at the -3 or the -1, just look inside the parentheses right here. Complete this square and build a trinomial square inside the parentheses. half of 2 is 1, 1 squared is 1. So if you add a 1 right here, now we have a perfect trinomial square in here. But now you need to ask yourself a question. What did you really add to this side? Because if you look at this distribution here, you didn't add a 1. You added whatever negative 3 times 1 is. In this case, negative 3 times 1 is negative 3. So in reality, you added a negative 3 to this side. Therefore, you must add a negative 3 to the other side. Have to do the same thing to both sides. That's the new step. Now this next step, and then we're almost here. Remember, this is our goal. Keep your goal in mind. Keep the negative 3. That is our A. Factor the perfect trinomial square that you just built, and then add these. Negative 1 plus 3 is negative 4. So now compare this to this. I'm not quite there yet. I need to get this 4 over to the other side of this, and then I'll bring my f of x back in. So now my f of x is equal to, the a in this case is negative 3. I have x minus 1 squared, and bring that 4 over as a positive. Now this is the vertex form. We are asked to state the vertex. So again, we just pull that out here. This gives me the x coordinate of the vertex. If this is a negative 1, the vertex x coordinate would be a positive 1. And this is over 4, so that's the y coordinate of the vertex. The equation of the axis of symmetry, x equals, it goes right through the vertex, goes right through the x. This screen is just a nice summary of what we've done so far with our notes on parabola from the first section, and what we learned about the vertex and the line of symmetry. So if you just want to pause it here and write this down, the only thing I can think of to add is to make sure you realize that this h here has the opposite thing going on. So if you want to write the word opposite down there or here, just to remind you of the fact that when this is negative, it's moving in the positive direction and vice versa. But this is a very nice summary. Okay, this next part is much easier than what you've just done. Going back to the standard form of a quadratic, we're going to learn how to find the vertex right from this standard form. First thing you do is find the h. The h is the x coordinate of the vertex. It's just minus b over 2a. And you'll notice I do not have a big fancy formula here. All you do is whatever x you found for the vertex, which is the h, you just plug it in. H is your input, and you just find the output. You find the y to go with it. So this is a very quick, easy way to find the vertex when you have the general or standard form of the quadratic. All right, last example here. When you're going to find the vertex algebraically, we need to pull out the a and the b. In this case, a is negative 3 and b is 6. I hope this example looks familiar because we just did this in vertex form. And now we want to follow to find our x coordinate of the vertex. It's minus b over 2a. So put minus 6 over 2 times negative 3, negative 6 over negative 6. So the x coordinate of the vertex is 1. And now to find the y, you go back here to f of x and you plug in the 1. So wherever you see the x, you put a 1. So putting in a 1 right here, we'd have negative 3 times 1 squared, which is negative 3. And 6 times negative 1 is negative 6 plus 1. And if we add this up, we get, whoops, I should put a plus sign there, sorry. Negative 3 plus 1 is 4. And that's kind of what we expected. So this is the y coordinate of the vertex. Algebraically, a little simpler than completing the square. Now we are to state the line of symmetry. Remember, this parabola opens downward because that's a negative sign, so if you want to picture it, it looks like this. The line of symmetry cuts right through the vertex, so the x coordinate of the vertex gives us our line of symmetry. All right, now I think you have the knowledge you need for section 6.2, so have fun with math.